y'all, we're gonna go really fast through these. Only because I'm running out of space on my phone, so it'll cut me off if we don't finish it. And if we don't finish it, I'll make a follow-up video. If it just cuts off, it'll be a follow-up. So basically, hold on, I'm skipping around here. This video is on non-ideal volatile solutions. What's that mean? We were doing ideal, non-volatile. And when it's non-ideal, that means both of the components in the solution can evaporate. They're volatile, they can both evaporate. Non-volatile means it doesn't evaporate. So in videos 1 and 2, the solute that was dissolved in water or the solvent, the solute was non-volatile, it did not evaporate. These are non-ideal. And we will talk about non-ideal versus ideal in either this video or the next video. So, here's a question though. Solution prepared by mixing 5.81 grams of acetone gives you the molar mass, and 11.9 grams of chloroform gives you the molar mass. And it basically wants to know at a temperature the solution has a total vapor pressure of 260 torr. So is this an ideal solution? Is this ideal? The vapor pressures of pure acetone and pure chloroform at 35 degrees Celsius are 345 torr and 293 torr respectively. All right, so what do we do, y'all? Well, we have to set up our equation. Here's our equation for this kind of problem. The other problem in videos 1 and 2, it was basically, I think it was basically that. Is that this was like the solvent, mole fraction solvent. But in this kind of problem where it gives you two substances, it gives both their vapor pressures, and you're looking to see what kind of, if it's ideal or non-ideal, you need to use this equation here. So total vapor pressure equals mole fraction of A times vapor pressure of A, and they give you that, plus mole fraction of B, chloroform, times vapor pressure of B, 293 torrs, which is chloroforms. Okay, so, all right, so first thing we need to do is find, whoa, almost knocked my camera over. All right, we need to find molar mass, mole fraction. These are our equations, remember that. So we convert grams to moles. Here we go. You have this many grams of acetone, gives you the molar mass, 58.1, and we end up with 0.1 moles of that. And then 11.9 grams of chloroform times 1 mole divided by 119 grams, which is the molar mass, 119, well, 0.4 grams, equals 0.1 mole. So you have 0.1 mole of both. Now what's the mole fraction? Come over here, plug in, you have 0.1 mole of this, plus 0.1 mole of the same thing, plus 0.1 mole of B. So they're both 0.1 mole. So 0.1 divided by 0.2 is 1/2. And it's going to be the same with this because these are the same. 0.1 divided by 0.2. Add those up. It's 1/2. So they're both 0.5 is the mole fraction. Okay, so mole fraction of both of these, acetone and chloroform, is 0.5. That's how much percent is in the solution. All right, now we have our equation. What happened to our equation? Here it is. All right, so we have the mole fractions, the XA and XB. Now we need the vapor pressure, so here we go. All right, so we'll plug in pressure total equals mole fraction of A times pressure of A. Now what's pressure of A? You find it in the problem down here. Right there. Pure acetone and pure chloroform. So pure acetone, which is A, is 345, which I have here, plus 0.5, which is mole fraction of B, times 293 torrs, which is the vapor pressure of chloroform, that's B. So you solve that and you end up with 319 when you add these up is the total pressure. Now is this ideal? It's 319 total pressure. All right, is it ideal? Yes or no or no. It depends if it's what way it is. So here's our answer, right? 319. Now why do I have 260 there? Because the problem says the vapor pressure, the solution has a vapor pressure of 260. So we're comparing the vapor pressure that we found, 319, to what they gave us, 260 up here, the solution. Not the vapor pressures down here, but the total solution. So 319 versus 260, is that ideal? No. Why? Because when they're ideal, then they're the same number, they're equal. So it's no, so we can cancel out yes. But what kind of